Welcome back to my course on From the Big Bang to Dark Energy. And as I emphasized in the previous lecture, we have learned tremendous amount of information about the universe over the past century or so. And I would like to address many basic questions about the universe, just like a little kid watching up the sky, being awed and impressed by the beauty of the universe. So naturally, we are all led to ask questions like, how did the universe begin? What is its fate? What it's made of? What are its fundamental laws? And why do we exist? In this universe, how do we come to exist? And all of these questions are now coming into the realm of actual scientific research. So we ask the questions about how things are around us. It's just the fact that there's day and night for seasons and motion of planets and so on. Eventually come all the way back to the beginning of the universe when the universe was only 380,000 years old. It was really a baby universe that let so much light out, we can still get to observe that hot universe still today. But we would like to even move beyond that. So when we ask the question, how do we come to exist? Of course, we need to understand where our material came from. We are made of atoms. So where did the atoms come from? At the very beginning of the universe, even atoms didn't exist. It was such a hot and dense soup of elementary particles, atoms actually did not exist. So we need to ask the question about the birth of chemical elements. Where did the elements come from? Also, it turns out that this question is related to something you might have heard about fairly recently, namely the Higgs boson that have been discovered last July at an experiment called LHC at the Swiss-French border. So we need to ask the questions about how the atomic nuclei had been formed, and that has happened when the universe was like 3 minutes old, and how the Higgs boson came to be and atoms were born that had to do with the time of the universe when it was only a trillionth of second old. So we are going back to even much closer to the beginning of the very Big Bang itself by studying the origin of the chemical elements and atoms. So that would be the subject today. So the second lecture is birth of elements and Higgs boson. So the first half is about the birth of elements. So this is a picture of cranky old TV. Many of you may have not even seen a TV like this in your life. But whatever the object may be, if you just slice it up into smaller pieces, eventually you arrive at atoms. Everything around us is made of atoms, and you know that. And atoms are made of electrons and nuclei. So it's sort of like a solar system where all the planets revolve around the sun. Electrons in atoms revolve around the nucleus. So that's the structure of atoms, as you already know. And atomic nuclei can be further divided up into smaller pieces, namely neutrons, which don't have electric charges, and proton, which has the positive electric charge. And if you look even closer, it turns out the neutrons and protons are not elementary objects either. They're made up of even smaller pieces called quarks. Both neutron and proton has 3 quarks inside, and we will briefly talk about that later. But you don't have to worry about it too much at this moment. And the point about the chemical elements when we talk about their origin is that you know what chemical element you're talking about once you know the number of protons inside atomic nucleus. So you glue neutrons and protons together to build up the atomic nuclei, and the number of protons is the key to determine the nature of that atomic element. So that leads us to the familiar table, which I'm sure you have seen hung on a wall in your science classrooms. That's a periodic table of chemical elements. And the thing about this table of elements is that there are so many elements out there, more than 100 of them, and our sort of the surroundings are made of out of about 90 of those. And you need all of these things to explain all the objects we see around us today. But it turns out at the very beginning of the universe, at the Big Bang, there were only hydrogen and helium. Hydrogen is here, whose nucleus is composed of just 1 proton and nothing else. And helium, which is made of 2 protons and 2 neutrons, and they are the only chemical elements that existed right after the Big Bang. But our body has a lot of other elements in it. We need carbon, nitrogen, oxygen. For example, even all the way up to iron, we actually need all of these elements to make up our body. So that's a natural question here. How were all these elements born when the Big Bang itself produced only hydrogen and helium? So that's the question to you. So how were the bigger elements formed out of the smaller elements?